Thank you for watching this Hexagon Geospatial e-training module, Build a Spatial Recipe using Spatial Workshop. In this module, you'll create a spatial recipe that shows the health of vegetation as a map, then create a Hexagon Smart Map to view the results. Indices are used extensively in mineral exploration and vegetation analysis to bring out small differences between various rock types and vegetation classes. Vegetation indices are mostly concerned with the reflection of near-infrared and visible red wavelengths in the electromagnetic spectrum. In this chart, you can see the differences among the average reflectance values of dying vegetation, bunch grasses, exposed rock, and shrubs. The Normalized Difference Vegetation Index, or NDVI, is a vegetation index of plant greenness, or photosynthetic activity. NDVI is commonly used to indicate the amount of vigor of vegetation in an image, or to differentiate vegetated and non-vegetated areas. NDVI is given as the ratio near-infrared minus red over near-infrared plus red. Higher NDVI values correspond to healthier vegetation, while lower NDVI values correspond to unhealthy vegetation or non-vegetative materials such as bare soil, concrete, or asphalt. In this module, you will build an NDVI spatial recipe and a simple smart map to test it and display the results. From M.App Studio, hover the cursor over Create New and select Create New Spatial Recipe. This opens the Spatial Workshop. The white space in the middle of the window is the view and is where you will build the spatial recipe. The Operators panel on the left side is used to select operators used in the spatial recipe. Drag and drop them into the view to build the spatial recipe. At the top of the Operators panel is a search bar. If you know which operator you want to use, you can search for it directly. From the Operators panel, drag the following operators into the view. 2 port inputs. One raster input. 2 band selection operators. 1 subtract operator. 1 add operator. 1 divide operator. And 1 raster output operator. Arrange the operators as shown in our example. Click the upper port input operator, Port Input 1. On the right side of the Spatial Workshop is the Properties tab. Use this to add values and define the operators. In the Properties panel, find the text box Port Input and rename it Multispectral Input. Click on the bottom port, Port Input 2, and follow the same steps to rename it Map Output. By using these ports, we allow the user to define the input image used in the model and provide a file name for the output when the model is executed. Select the raster input operator. In the Properties panel, change the data type to float. The data type definition is case sensitive, so be sure that the F is capitalized. The NDVI equation results in values that range from -1 to +1. In order to properly display the output data values, float data is needed, so the decimal values are used. The default output type for this operator is integer. Using integer data would cause all the values to be truncated. For example, 1 divided by 2 would result in 0 instead of 0.5 as the value. Select the upper band selection operator and rename it NIR band. Select the band range port in the Properties panel and change the value from empty to 5:5. This indicates that band 5 is to be used as the near-infrared band. Select the lower band selection operator and rename it red band. Select the band range port and change the value to 4:4. This indicates that band 4 is to be used as the red band. Now you'll begin to make the appropriate connections among the operators. Click the Multispectral Input port and connect it to the file name port in the raster input operator. On the raster input operator, connect the raster out port to both NIR band and red band raster in ports. Select the NIR band raster out port and connect it to both subtract input 1 and add input 1 ports. Select the red band's raster out port and connect to both subtract input 2 and add input 2 ports. Connect subtract output port to the input 1 port on the divide operator. Connect the add output port to the input 2 port on the divide operator. Connect the divide output port to raster output, raster in port. Finally, the output map operator connects directly to the raster output operator to supply the output file name. Connect output map input port to the raster output file name in port. In the title bar in the upper left of the window, change the name of the recipe to NDVI. Click Validate to test your spatial recipe and check for errors and ensure it runs as expected. Validate ensures all syntax is correct, required connections are made, and the correct data types are defined. In short, it ensures the model has all necessary information to run. Click Save. Click the Recipes tab. Select your recipe from under the Saved menu, and then click Publish to make the spatial recipe available in the M.App Studio. Open the drop-down for the Publish tab to double-check that the recipe has successfully published. Return to the M.App Studio and click Recipes to see the published spatial recipe. Now that you have created a spatial recipe, you'll need to test it. Build a small smart map to run the recipe and display the resulting NDVI image on a base map for interpretation. In the M.App Studio navigation bar, select Create New Map. The first step, Design, defines the layout of your application. From the Toolbox panel, use the Predefined Layouts menu to select the vertical 2-panel layout and drag and drop it to the view. Modify the size of the panels by selecting the panel separator and moving it to the left. The left area will hold a simple geoprocessing panel, and the right area will hold the map view and display the results of the spatial recipe. In the second step, Build, choose your application content within each panel. Click Build. From the toolbox, drag Recipe into the center of the small panel layout. This is the geoprocessing panel. Select your NDVI Smart Map recipe. Click OK. Next, from the toolbox, drag and drop Map over the larger panel. To define the map, select Milton Keynes to use as the base map. Click OK to close the Select Map window. Now, customize the geoprocessing panel. In the navigation bar, click Customize. From the Recipe panel, click the JS button to input predefined JavaScript. In the toolbox, expand the Code Examples menu. Scroll down to the Catalog Operations folder. Drag and drop Publish Catalog Item and Send to Map into the view. Click the X to close the JavaScript window. From the Map panel, click the JS button to add the JavaScript. In the Code Examples under the Map Operations folder, drag and drop Add Catalog Item to Map. Close the JavaScript dialog. Rename your Smart Map Test NDVI. Click Save to save the Smart Map. Click Close. Click Close Map Editor. Select My Maps. Select Test NDVI and click the Run button. Your app will run in a new web browser tab. From the Multispectral Input drop-down menu, select the multispectral image. In the Output Map text box, type Milton Keynes NDVI. Click Execute to run your spatial recipe. When the process completes, the result is placed into Map Chest and displayed in the Map window. You now see the results of the spatial recipe displayed in the Smart Map, confirming the results. Thank you for watching this e-training module from Hexagon Geospatial. For more e-training, please visit hexagongeospatial.com/e-training.